Hello and welcome to Sean White's Solar and Energy Storage Podcast. This week we're going to cover PV, markets and applications part 2. That's of a part 3 series. And what we're going to talk about here is utility interactive PV systems, direct current, alternating current, the 5-minute UL 1741 anti-islanding requirements, PV as the anti-load, net metering, residential and commercial voltages, 12240 volts, 12208 volts, 277 480 volts, delta, stinger, medium voltage, high voltage, and ultra high voltage connections. We're going to mention the real Tesla, that's Nikola Tesla, utility scale PV, National Electrical Code Article 691 for large PV systems, charge controllers, standalone, that's off-grid systems, rectifiers, that's charging with AC to DC, the Tesla Powerwall, which is AC coupled, PV and batteries, and then we're going to talk about the DC coupled SolarEdge storage. So to find out more, go to solarsean.com. Now, on with the show. Okay, folks, so this is the second markets and applications, and we just went through from grid tied through concentrated. And now what we're going to do is we're going to hit these subjects at a different angle to get them to sink into your cerebrum. That's part of your brain. Utility interactive. All we do is we just hook it up to the grid and the sun turns it on. The sunlight turns it on. Yes, we also do have AC and DC disconnects, but just to make things a little bit simpler, we've got PV, which is of course DC. It goes to the inverter and then it turns into alternating current. Grid tied, or the more proper term is interactive. So what it does is it sees frequency, it sees voltage from the grid, and once it has waited a certain amount of time, which is 5 minutes according to the UL 1741 requirements in the United States of America and Canada, other countries might have a different time requirement of sampling the grid than 5 minutes. So once you hook up your inverter and you turn on the circuit breaker, then you have to wait for 5 minutes while that inverter sees the grid before the inverter will start pushing current back towards the grid. That's 5 minutes, and that's also 300 seconds. So the inverter will wait for 300 seconds. If during those 300 seconds you turn off the inverter for a split second, then the clock starts over and you have to wait another 300 seconds. Some inverters will even have a countdown. So don't be impatient. Make sure to be able to wait for your PV system to turn on. It's kind of funny. With PV, everything is the opposite. I like to call PV the anti-load because things go in the opposite direction. It's sort of like the interactive inverter is the power supply and the grid is the load, in a way, philosophically speaking. So we've got sunlight, solar energy going to the solar modules. Some people call them solar panels. Going to a grid tie inverter, down to a circuit breaker, to the meter, to the grid. However, if you're using a lot of power at your house, you might be taking power from the inverter and from the grid at the same time. It all balances out, and that's called net metering. Net metering means that you can export to the grid for credit and use that electricity that you sent to the grid at a different time of the year or a different time of the day. Interactive inverters can come in all sizes. The popular small interactive inverter called a microinverter. Particular brand is called Enphase, and they are the second biggest inverter company on the residential market in the United States. And these inverters do anti-islanding on a PV module basis. On the other hand, you can have huge interactive inverters that are multiple megawatts in size. All these inverters do UL 1741 anti-islanding. That means that when the grid goes down, they turn off. They can't send out power without a grid. I'm going to talk about different grid voltages and try not to get you overwhelmed because this can be overwhelming and it borderlines on the advanced realm. However, just so you know what grid voltages are in different places, this is what we see mostly in the United States and Canada and a lot of countries close to the United States, such as Mexico going down towards South America. But then once you get into South America, you start to see more European cobblestone streets and European voltages. For residential voltage, is called 12240. That means that we're never more than 120 volts from ground. Things that you might touch, such as light sockets, are at 120 volts. However, you can have some larger appliances such as air conditioners and stoves and electric dryers and electric cars and your PV inverters working at 240 volts. But those aren't things that normal people will plug in, except for the EV, and there's special safety requirements there. Now, commercial voltages typically is what we're going to see is on smaller commercial, it's going to be 120 208 volts, so 120 times 1.73, which is the square root of 3, equals 208. We're talking triangles here, folks, trigonometry, and we're not going to get too much deeper than that, but just to let you know what we have. Then 277 480, that's what you see on larger commercial services. Service means that's how the utility serves it to you. Other words that you might hear are 240 delta and stinger. Just so you know, those are just different kinds of complicated trigonometry style three-phase connections that you might have to the grid. Then for utility scale, you're talking medium voltage, and medium voltage is really high from a building point of view. Medium voltage means thousands of volts. And then you can go from medium voltage transformers at your utility scale grid up to even high voltage. And sometimes we even talk about ultra high voltage connections. These are things that only very specialized people are going to be working on. But just so you know that it's out there. And know that the higher the voltage, the lower the current. So the reason that we have high voltage, which can get kind of arcy and sparky, is so that we can transmit electricity over smaller wires or longer distances. That's why Tesla, the Nikola Tesla, the original Tesla, was so famous, because he figured out how to make three-phase electricity boost and drop voltages so you can transmit electricity over longer distances. Residential size PV systems are usually under 10 kilowatts. Commercial size can be megawatts, and utility scale is oftentimes over 5 megawatts. We have a special article in the National Electrical Code called Article 691, which covers systems that are over 5 megawatts that don't have to follow the same rules as our smaller PV systems. For a possible exam question, the charge controller prevents over and undercharging of the batteries, whether it be a charge controller on a grid tie battery backup system or a charge controller on a standalone system. A charge controller controls the charge. So remember, the official term for a type of a system that doesn't connect to the grid is called standalone, and the unofficial term is called off-grid. One part of a charger too is called a rectifier. So sometimes a charger can be called a rectifier because it is rectifying AC into DC to charge the batteries. Sometimes what we're seeing in this modern age is the battery inverter and the energy storage system is all in one device. That's the way that Tesla Powerwall does it these days. So you would have an energy storage system and an inverter charger that's all in one, and that would be an AC coupled system. If you're working with SolarEdge and doing energy storage, they have a DC coupled solution. So that means that you have the PV and the energy storage coming together on the DC side of an inverter. So they're coupled together on the DC side. Test questions that you might see on the NABCEP PVA, that's PV Associate exam, might sound something like this. What would you see with an AC coupled system? And the AC coupled system would have two different kinds of inverters. It would have a battery inverter and it would have an interactive inverter. This is the end of the part 2 of PV markets and applications. Stay tuned for part 3. Thanks for listening to Sean White's Solar and Energy Storage Podcast. Stay tuned for part 3 of PV markets and applications next week. And to find out more, go to solarsean.com.